All right, welcome everybody. This is section 5.4. 5.4 is titled The Fundamental Theorem of Calculus. And when we're talking about that, the calculus 2, taking the integration, integrating a function is finding the area under the curve. If you look at a function, its first derivative is finding the slope of that function. If you integrate the first derivative, we change that to a capital F. If you integrate a derivative, we change that back to the function, but we use a capital F showing that you integrated a function. And integrating a function is finding the area under a curve. Area under a curve. And when we do this, we integrate the function. Once again, we're going to integrate it between two spots, between two numbers. And this is usually the lowest number. It's always the lowest number, and this is the highest number. If you watch a video on 5.3, it talks about if the low number and the high number are switched, what you have to do with that function, and you can take a look at that. But when you integrate a function, do you see it turns into a capital F? And the top number is always the number you plug in first, the highest number, and then the lowest number is the number you plug in second, the lowest number, and you subtract the two. So that's the integration part. And I want to show you a quick example using my calculator. So let's do integration using the calculator really quick. Let's integrate, and I'm going to write this down here. So before we even begin, here's my function x squared, and I want to integrate this function. Let me write it as x squared. Let me put the x squared in there. I want to integrate x squared. And if I integrate x squared, remember you have to add 1 to the power. And then you divide by that power. And if I want to integrate, I'm going to integrate from 0 to 2. So I'm going to integrate from 0 to 2. So this is the integration formula. First, what this function says is first you plug the 2 into here. 2 to the third power over 3. Then you plug the 0 in there. 0 to the third power over 3. And then you subtract the 2. And 2 to the third power is 8 over 3. 8 over 3 minus 0 is 8 over 3. So let's do this on the calculator now. So I got an 8 over 3 for this function. Let's do this on the calculator. I'm going to write in the function x squared, just like I said, x squared. I want to graph it. There's my x squared. And now I'm going to use the calculator to integrate it. Finding the area under the curve. And let's see if I can remember how to do that. Something about math. Math. What is it? Math? Is it math? I don't even think it's math. No, it's where is it? Any math?
Math, and then go down to 10.
10. There we go. Thank you. No, that's summation. I want to do integration. So, okay. So this is how I integrate. First of all, y equals math 10 is summation, is the way we got the answer when we added up the rectangles in the circle underneath the curve. But we're going to actually have the calculator find the exact answer here. So what we're going to do is we're going to go to calculate on top, this blue calculate. Second, calculate. Second, calculate. Yes, number 7. So let me write this down. Integration using the calculator. This might be cheating for you guys since you don't have to show any work on the test. But integration on the calculator is second. And then we push the trace button, which is calculate. Second trace, and then you go down to number 7. If I can get to number 7. Go down to number 7. You see number 7 shows that integrating a function. Hit enter. And we're integrating from the lowest level. We're starting at 0. And then the upper level is 2. And when I hit enter, do you see it finds the area under the curve between 0 and 2? And my answer is 2.66666666. In other words, it's 2 and 2/3, which is the same thing as this, 8/3, 2 and 2/3. You see, you manually can do it, or you could do it on your calculator. So let me, before we do any more, let me write all the steps to do it on our calculator. So make sure everybody has it down. And the steps were, step 1, plug function. I'm sorry, this thing is all over. I don't know what's going on here. My pen. Plug. Into y equals. So we want to type in our function into y equals. Step 2, graph it. Step 3, second trace, which is really calculate, and then go down to number 7, integrating a function. And you're going to put the low number in, low, hit enter, and then the high part you're integrating to, hit enter, and then hit enter one more time. So that's how you find it. On your calculator, you go to y equals, you type in your function. I typed in x squared. Then I hit graph. Make sure you should be on -10, 10, -10, 10. And then I go to second calculate, number 7. The low number we're integrating, we were integrating from 0 to 4. No, 0 to 2 for this function, for the function x squared. So we hit 0 for the low, hit 2 for the high, and when we hit enter, it tells us our answer. By the way, it won't clear, so you see how it didn't erase. If you want to clear it, type in a different function, or type in different numbers, and then you come back and type in the function again. Once it's there, it doesn't erase unless you change the function or something. So that's how you integrate. So let's go through these. I mean, we're not doing this all on our calculator. I'm going to show you how to manually do all this, but you should be able to do it on your calculator also. All right, so let's integrate this problem. So first, we're going to integrate this. We're going to integrate it, right? If you have two terms together, you integrate the first term, and then you integrate the second term, and there's a subtraction between the two. So you can integrate them separately, just like when we took the derivative, you take the derivatives of each term. So integrating this x squared, we already know you add 1 to the top. This is what I get, and then you divide by the new power. The new power is 3, so we divide by that. Here we have a 3. And remember, integrating a constant, ends up, constant is like x to the 0. So you add 1 to it and you get x. And then you divide by the 1, which doesn't change anything. You divide by the 1 and this is what you get. So this is our integration. When we integrated this, this is the answer. And what the book normally does now, and they show 2 and 1, they put it in a bracket and they show 2 and 1. So first we plug 2, the top number, the highest number, into the function. When I plug 2 into the function, 2 to the 3rd power is 8. Plug 2 in here, 2 times 3 is 6. So that's the first part. And then you have to subtract the second part. Plug 1 into the function now. 1 to the 3rd power is 1, divided by 3 is 1/3. Plug 1 into the function here. 3 times 1 is 3, minus 3. And this is our answer. You plug 2 in, and then you subtract and plug 1 in. And so I'm going to put all that on my calculator, nice and simple. 8 divided by 3 minus 6, and I get an answer. And then I'm going to subtract, parentheses, 1 divided by 3 minus 3, close parentheses, and I get an answer. And if you look, the answer is, and I don't want answers in decimal form, negative 2/3. By the way, you should be able to just hit math number 1, and it'll change the decimal to the fraction, negative 2/3. So when we integrate this function from 1 to 2, you should get a negative 2/3. Let's see if I can do this on my calculator. The calculator sometimes on these is a little tricky. So I'm going to hit y equals, and we're integrating x squared minus 3. When I hit graph, this is what I get. And I am going to do second calculate. I thought I hit second. Oh, I did hit the wrong number. Second calculate. Number 7. From 1 to 2. And if you look at it, I get the same answer, negative 2/3.
So right after we hit second trace, we hit enter, then we hit 1, then we hit enter, then we hit 2.
Yes.
Okay.
So let's try that. I mean, first you graph it, then you do second trace and go to number 7. And it says your lower value was 1, and then your upper value is 2, and then it does it for you.
Okay.
From 1 to 2. Do you see how? And this is important. Do you see how the area is underneath the x-axis? That's anything below the x-axis counts as a negative area, the negative y. So anything below the x-axis is a negative area. Anything above the x-axis is a positive area. Okay, so I just want to make sure everybody gets that. All right, so let's keep going. So you could do it manually, or I mean, I would learn how to do both ways. Let's look at the next one. Secant square. So I want to integrate just secant square. By the way, I want to integrate secant square x. Look on your calculus formula sheet, and I haven't found that new formula sheet for you guys yet with more stuff on it, but I will find it for you. So look under integration and see if you see a secant square x. I see one. This integrates, so we're looking to integrate secant square x. Don't forget, another way of writing secant square x is this, secant x squared. They both mean the same thing in trig. When you integrate secant square x, if you look at your formula sheet, it becomes tangent x. Integrating secant square on your formula sheet is tangent. It's on your calculus integrals in the upper right-hand corners. Integrating secant square x changes to tangent x. And when we're plugging numbers in here, we don't add the c's to it. Just let you know, because there's no constant in this particular function. So this is the function. We're going to plug, I mean, do you see there's no integration anymore because we already integrated it. And we're going to integrate this from pi over 4 to 0. So first we put the function with pi over 4 in it. Then we put the function with 0 in it. Do you see this is the first one? The top is the first you plug in. And then this is the second one, 0 you plug in, and you subtract the 2. Tangent of pi over 4 is 1. You go to your unit circle. Pi over 4 is square root of 2 over 2 over square root of 2 over 2. Sine over cosine. Same thing divided by the same thing. It equals 1. Tangent of 0 should equal 0, right? Sine over cosine. 0 over 1 is 0. So this equals 1. Integrating secant square x between 0 and pi over 4 should yield you 1. Let's see if we can do that on our calculator. I'm trying to make this bigger. So I'm going to type in my y equals to secant square. How come I can't make this bigger? What's wrong? It won't. I guess that's as big as it lets me. Secant square x. Oh no. I mean, is there a secant on here? How do you do secant? Anybody know? We have to type in this. How do I type this into my calculator? I don't see a secant on my calculator. Would you agree that secant is 1 divided by cosine? Isn't that right? And then I'm going to square it. Secant, do you see secant is 1 over cosine? And so this is secant squared. When I graph that, I get this crazy thing. And I'm going to graph it from 0 to 2 pi. Let's see what that gives me. I don't know if this is going to be right. Maybe I typed something in wrong. Second trace from 0 to 2 pi, 2 times pi. It's not letting me. I must have did something wrong. Those secant squares, when you type those things in, it's always, oh wait, it's not on my yx anymore. Did I not type it in? Let me try this again. I'm sorry, 1 divided by cosine secant. I got to put the whole thing in parentheses. 1 divided by cosine x parentheses raised to the second power. It was there, but it didn't take. Yeah, that doesn't, because it goes up to infinity. I think I did something wrong here. From 0. It's really taking his time thinking. Still waiting, still waiting. It's I don't know if this thing's gonna even it says it's calculating it. So I'm not able to type that. Anybody know how to type in that secant squared into the calculator? Let me try something. Oh my God, now it won't even let me. My calculator, oh, there it goes. My calculator was thinking. I might do this. Secant is 1 over cosine. I don't think you can do that. Let me see. Oh, it's pi over 4. That's, I was doing something else. Let me go back. Did anybody get the right answer? Just checking. Secant square, once again, parentheses. I'm going to get it divided by cosine x, close parentheses, square it. And there we go. Let's see if this works. And we're going from 0 to 2 pi over 4. Number 7 from 0 to pi divided by 4. There we go. Oh, Lord. Okay. And we got 1. So let me show you how I typed it in, just like I said I was doing. Secant is 1 over cosine. So I did the parentheses, 1 divided by cosine x. Close that parentheses and close the whole parentheses. So I have 1 over cosine, and then I squared it. And then when I graphed it, this was the graph, and I'm going from 0 to pi over 4. So I do second trace, number 7, and I go from 0. Now I got to do pi over 4. There's pi. That's not pi. I can't see, sorry. There's pi. From pi divided by 4. Do you see pi over 4? That's my upper, and then when I hit enter, it gives me 1, an area of 1 from 0 to pi over 4. All right, so I got that. So to type in a secant on your calculator, since there is no secant, by the way, secant is not 1 over cosine. It's not cosine to the negative 1. That's the inverse cosine. Secant is 1 over cosine. So you have to actually type in 1 over cosine. That's the secant, and then you square it. All right. Everybody okay with that? If you guys are still with me. Yeah, I didn't type in pi over 4. Thanks, Ian. I typed in pi over 2, and then which gives it an error because that's undefined at that point, at tangent. All right. Next, integrating from 0 to e, and we're going to integrate 1 over x. Well, first we have to integrate 1 over x. Go to your formula sheet, and you can integrate. It tells you integration of x to the minus 1, right? The formula sheet shows this, which is the same thing as integrating 1 over x. 1 over x, it changes to, the integration is the natural log of x. So this integration is the natural log of x. And we're integrating from 0 to e. So first you plug the e into it, natural log of e. Then you subtract and plug 0 into it, the natural log of 0. Natural log of e, you plug that in your calculator of 1. It's e to the 1 power. Natural log of e is 1. And try the natural log of 0 on your calculator. You're going to be, anybody know what that equals before typing it in? You can't take the natural log of 0, so it says error, you see. So it's just 1 minus an error, or you can, I think we can just say 1 minus 0. So the answer is 1. Let's put that in our calculator. Let's see if that actually gives us an answer. By the way, let me see what the book says to that. Wait, oh, I typed it in wrong. I typed this problem in wrong. I'm sorry. That's why, because you take this problem in the book, you can't have 0. I'm thinking the natural log is 0, by the way, is error. So you can't do that. I thought I typed it in wrong. I'm glad I checked the book. We're going from 1 to e. So we plug e in first. We did that. Then you plug 1 in. And the natural log of 1 on your calculator is 0. That's where we get the 0. So this was wrong in the PowerPoint slide. And then 1 minus 0 does equal 1. So let's plug this into my calculator, and let's see if we can integrate that using the calculator. 1 over x is the function. 1 divided by x. And when I graph it, that's 1 over x. And I want to integrate it from 1 to e. So I'm going to integrate it. Second trace, number 7. From 1 to e. And to do the e, it's this right button right. Where's the e? It should be by the ln. There it is. Second ln. It says e to the, and it just says e to the power. E to the 1 power is e. So you have to put in there e to the 1 power. So from 1 to e, and when I hit enter, you see it gives me the area that's shaded in, and the answer is 1. 1 minus 0 equals 1. All right, so these are really great to check on your calculator. I think I might not have a lot of these on the test. I might have the actual integration where you just, we'll see what we have on the test anyway when we get there. All right. I know they're good. All right, so the mean value theorem, or finding the average value of a function in an interval. So we've done this a lot. Last test we had to do that too. Don't forget, to find the average, it's the same, it's the same way as we found slopes before. You have the y2 minus y1. And then you have the x2 minus x1. And these are the x's. Do you see x2? So x2 minus x1 are on the bottom. And then here is the y2. You put the 2 in there first, minus y1. So what this is the change in y divided by the change in x. Okay, I mean, if you do this function, let me just show you. If you do this function, it changes, the function changes to a capital F. saying, hey, we did this function. We're going to integrate this from A to B. Here's our A to B. And then we're going to divide it. We're going to plug B into the function first. Then we're going to plug A into the function. We're going to subtract it. And then we're going to divide it by B minus A. B minus A. So, I mean, that's exactly what we have here. That's what we've been doing. And except, I mean, it's the same as integration other than dividing it by the B minus A. Okay, so it's the same thing. So let's do the example. I think this is the last example we have. Find the average value of this function between 1 and 4. So we're going to integrate this function. Let me start off right here. We're going to integrate 3x squared minus 2x from 1 to 4. Do you see the lower and the upper, the lowest and the highest, integrating from 1 to 4? And then we're going to divide it by 4 minus 1, the B minus A. This is the A, and this is the B. There's the A, there's the B. 4 minus 1, 1 over 4 minus 1 is 1 over 3. So integrating this, let me change my color. So let's integrate this first. You add 1, 3x to the third power, and you divide by the new power, 3. Then we integrate this one, 2x. There's a 1 there. If I add 1, I get 2x squared, and I divide by the new power. And we're going to integrate from, once again, 1 to 4. So we plug 4 into here and find the answer. Then we plug 1 into there. So I'm going to start with just 1/3, and we're going to plug 4 into, oh, wow, this is going to be larger than I thought. 3 times 4 to the third power. Oh, the 3's cancel, by the way. You can just do 4 to the third power. And I get 64. And then these 2 cancels, and 4 to the second power, 4 times 4 is 16. 64 minus 16. And I get 48. So when I plug 4 into here, I get 48. Now let's plug 1 into here. 1 to the third is 1. Minus 1 squared is 1. Get 0. So it's 48 minus 0 is 48. And 1/3 of 48, 48 divided by 3 is 16. So we should get 6. That's the average value. That's not the integration. It's the, I mean, the integration, we ended up with 48. When you find the area, the integration was 48. But then find the average value of that spread over a distance of 3. Do you see? Spread over a distance of 3. So the average area is 16. The total area is 48, but the average area is 16. So that's what they say when find the average value of a function. It's integrating, but then dividing it by how long you're integrating by. And we're integrating from 1 to 4, so we're integrating by 3. 4 minus 1 is 3. And there's no average value on our calculator, but let's integrate that function just and see if we get the 48 like we're supposed to. So we're going to integrate 3x squared. Make this bigger for me. Minus 2x. So there's our function. Let's graph it. And we're going to integrate it from 1 to 4. Second trace, number 7, integrating from 1 to 4. And do you see how I got 48? And the average value then would be 48 divided by the distance on the x-axis, 4 minus 1. The total distance is 3. So 48 divided by 3, the average value is 16. So be careful what they ask for. And that is the end of